Hello friends, in the last lecture we have seen the Bernoulli differential equation, and the Bernoulli differential equation is reducible to the linear differential equation with standard form. Now today we are going to learn linear differential equation with constant coefficients of higher order. Linear differential equation with constant coefficients. Okay, so what are the linear differential equation with constant coefficient of higher order derivative? Linear differential equation with constant coefficient coefficient of nth order, coefficients of nth order is given by a naught d raised to n y upon dx raised to n plus a1 d raised to n minus 1 y divided by dx raised to n minus 1 plus a2 d raised to n minus 1 y divided by dx raised to n minus 2. Okay, and plus so on up to a n y, and this equal to x, where a naught, a1, a2 up to a n are coefficient constant, you can say only constants. Okay, and x is the only function of x, and x is the only functions of x. Okay, for the solution of differential equation, the operator d by dx is denoted by dx. So and operator d by dx is denoted by capital letter D. Okay, so the differential equation becomes, means the given differential equation become, name this equation number star. So the given differential equation becomes, therefore the given differential equation star, which differential equation star becomes, so instead of d by dx we put here d, so this becomes a naught d raised to n y plus a1 d raised to n minus 1 y plus a2 d raised to n minus 2 y, and plus up to plus a n y, and this is equal to x. Now y is common in each term, so we will take y as a common, so this become a naught d raised to n plus a1 d raised to n minus 1 and plus a2 d raised to n minus 2 and plus up to a n, and we will take common y from each term, and this equal to x. Okay, so therefore this become f of d is the function of d, and y, and this equal to x, where a naught d raised to n plus a1 d raised to n minus 1 and plus a2 d raised to n minus 2 and plus up to a n, and this equal to what? This is the function of d. Okay, this is the function of d. Now the general solution of this differential equation star consists of two parts. Consists of two parts, namely complementary function and particular integral. Namely complementary function. In short, you can say CF, and particular integral. And you can write in short PI. Okay, and a part of general solution which consists of arbitrary constant is known as complementary function. So here we define a complementary function. So what is the complementary function? A part of general solution which contains arbitrary constants is known as complementary function. Or you can say CF, complementary function, that is YC. Okay, the general solution is given by, therefore we can obtain the general solution. Therefore the general solution is given by YC is given by, we have to find out the general solution. So the general solution is given by YG, or simply you can say Y, and this is equal to what? YC plus YP, where YC is the complementary function and YP is the particular integral. Okay, now there are methods to find out the complementary functions depending upon the nature of the roots of auxiliary equation. Okay, so let us move for the next page. The method of finding complementary function. Method of finding complementary function CF. Okay, since we know that the given differential equation, we know that the given differential equation can be written as f of dy, and this is equal to x, where x is the only function of x. Okay, so for complementary function we put f of d equal to 0. Okay, so this is known as auxiliary equation. So this is known as auxiliary equation. auxiliary, this is known as auxiliary equation. Okay, that is what A dot E, auxiliary equation. Okay, so let, if I suppose m1, m2, m3 up to mn be roots of auxiliary equation, then depending upon the nature of these roots, the complementary function can be determined. Then depending upon nature of roots, the complementary function can be determined. Okay, as follows. So there are 4 cases to find out the complementary function. So case number 1. So what is the case number 1? If roots are real and non-repeated. If roots are real and non-repeated means distinct, then what happen? If roots are real and non-repeated. Now if I suppose if m1, m2, m3 up to mn are real roots and non-repeated then we can write the complementary function yc equal to c1 e raised to m1x plus c2 e raised to m2x and plus c3 e raised to m3x and plus up to what, plus cn e raised to mnx. So here if roots are distinct and real, then yc can be written as c1 e raised to m1x plus c2 e raised to m2x plus c3 e raised to m3x and plus so on up to cn e raised to mnx. Okay, so there are n distinct roots, so there will be n arbitrary constants, that is c1, c2, c3 up to cn. Okay, now case number 2. What is the case number 2? If roots are real and repeated. If roots are real and repeated. Then what happen? Suppose root m1 repeated 4 times. m1 repeated 4 times and m2 repeated twice. m2 repeated twice and other are distinct and all other roots are distinct. All others roots are distinct. Then what happened? Then we can write the complementary function yc equal to m1 repeated how many times? 4 times. So for this we write c1 x raised to 0 plus c2 x raised to 1 plus c3 x square and plus c4 x cube and e raised to m1 x. So this is for the root m1. Okay, plus the second part, that is m2 repeated how many times. Suppose m1 repeated 4 times and m2 repeated how many times. M2 repeated and m2, that is what, m2 repeated how many times, 2 times. M2 repeated twice. Okay, suppose m1 repeated 4 times and m2 repeated twice and all other roots are distinct, then yc equal to c1 x raised to 0 plus c2 x1 plus c3 x square plus c4 x raised to q into e raised to m1 x. Okay, and m2 repeated twice. See here, c1 c2 c3 and c4 constants we already taken, so we take another constant, that is c5 and plus c6 x into e raised to m2x. Okay, and plus all other roots are distinct, so we write, since c5 and c6 already taken, so we take c7 e raised to m3x plus c8 e raised to m4x and plus so on up to what, up to cn e raised to mn x. Okay, so if roots are real and repeated, then we can write complementary function like this way. Okay, that is, if m1 repeated 4 times, then we can write c1 x raised to 0 plus c2 x raised to 1 plus c3 x square plus c4 x cube into e raised to m1 x. And if roots are m2 repeated twice, then we can write c5 plus c6 x e raised to m2x and plus, and all other roots are distinct, so we can write as it is, that is c7 e raised to m3x plus c8 e raised to m4x and plus so on up to cn e raised to mn x. Okay, now case number 3. Case number 3. Okay, if roots are complex number and non-repeated, then how can write complementary function? If roots are complex, number and non-repeated, then what happen? Now if m1 is alpha plus I beta, we know alpha plus I beta is a complex number, then for any complex root there will exist its conjugate pair. So m2 will be what? Complex conjugate. m2 equal to alpha minus I beta is its complex conjugate. Okay, then the complementary function is given by yc equal to c1 cos beta x and plus c2 sin beta x. Okay, so into e raised to alpha x. Okay, so here we ignore the complex conjugate root. We will take only positive root, that is m1. Getting? So here your beta is imaginary part and alpha is what? Real part. So this can be written as what? C1 cos beta x plus C2 sin beta x into e raised to alpha x. Getting? Now case number 4. Let us move for the next page. Case number 4. Case number 4. What is the case number 4? If roots are complex number and repeated okay, then how to write the complementary function? Suppose root m1 is repeated, that is what? Alpha plus minus I beta is repeated, okay. Then what? Repeated how many times? Repeated twice, okay. Then we write yc, that is complementary function, yc equal to c1 plus c2x cos beta x and plus we write c3 plus c4x sin beta x, okay. This is for real part. This is what? This is for positive roots, okay. So yc equal to c1 plus c2x into cos beta x plus c3 plus c4x into sin beta x. This is for imaginary part, and into e raised to alpha x, where alpha is what? Real part. So this is your required complementary function if m1 repeated twice, okay. If m1 repeated twice, okay. So in this way you can determine the complementary function. The complementary function depend on the nature of the roots. So there will be the 4 cases: if roots are real and non-repeated, if roots are real and repeated, and if roots are complex and non-repeated, and if roots are complex and repeated, okay. Now let us do the problem based on this, then you can understand this concept very nicely, okay. So example number 1. Find the complementary function. Find the complementary function of the following. Find the complementary function of the following. Complementary functions of the following differential equation. Okay. First one is, we write first one. What is the first one? That is d square and plus 5d and plus 6 and y, and this equal to 0, okay. Now solution. Let us see how to find the complementary function. So first of all, we write the given differential equation as it is. So given differential equation, d square plus 5d and plus 6, okay, into y, and which is equal to 0, So for complementary function CF, we put d square plus 5d and plus 6 equal to 0. So which is a auxiliary equation, which is an auxiliary equation, okay. So the complementary function depends on the nature of the roots of auxiliary equation. So we find the roots of this auxiliary equation. So we first factorize this. So d square plus 5d and plus 6 equal to 0. Now factorize this. So what are the factor of this? We multiply 6 into the coefficient of d square, that is 6 1 is 6, and find the factor of 6 such that their sum is 5. So d square plus 2 d and plus 3d and plus 6, and which is equal to 0. So we take d as a common from first two, so d plus 2 and plus 3 is a common from last two, so d plus 2 and this is equal to 0. So this can be written as d plus 2 and d plus 3, and which is equal to 0. So this gives d plus 2 equal to 0 or d plus 3 equal to 0. So this gives d equal to minus 2, or you can say d equal to minus 3. Okay, which are real and distinct roots? Which are real and distinct root, means non-repeated root. Distinct roots. Okay, that is what? Non-repeated. Okay, therefore the complementary function is given by, the complementary function is given by what is the complementary function? Yc equal to, roots are distinct, so there will be two constant, that is c1 e raised to negative of 2x and plus c2 e raised to negative of 3x. Okay, which is require complementary function of the given differential equation. Okay, for more understanding, let us take another example number 2. So let us move for the next page. Example number 2. Okay, so your example number 2 is d square y upon dx square and plus 9y, and which is equal to 0. Okay, so solution of this, what is the operator here? D by dx is the operator, so instead of d by dx we put here d. So this become what? D square y plus 9y equal to 0, where we can say d by dx equal to the operator capital D. Okay, now y is a common from each term, so we take common, so d square plus 9y, and which is equal to 0. Okay, so now we find the auxiliary equation. So what is the auxiliary equation? So for complementary function we put d square plus 9 equal to 0, so therefore d square plus 9 equal to 0. Okay, which is auxiliary equation, which is an auxiliary equation. So now you have to find out the roots of this auxiliary equation. So this can be written as what? D square equal to minus 9. So d square minus 9, so d equal to minus plus minus, you can say square root of minus 9. Okay, so therefore we write d equal to plus minus square root of 9. This can be written as 9 into square root of minus 1. Okay, so if you solve this, this gives plus minus square root of 9 is 3 and square root of minus 1 is I. Square root of minus 1 is I. Since you can write here square root of minus 1 equal to I. I means what? Iota. Iota is a complex number. Okay. So this can be written as simply 0 plus minus 3 times of iota. Okay. So which is the distinct complex root? Which is complex root, or you can say which are, because there are two roots, which are complex root and non-repeated. Therefore the complementary function is given by, therefore the complementary function yc is equal to c1 cos beta x, beta is here 3x plus c2 sin 3x into e raised to alpha x. Alpha is a real number. Okay, alpha is a real number or real part. Your real part is 0, so e raised to 0x. So this can be written as c1 cos 3x and plus c2 sin 3x. Okay, which is require complementary function of the given differential equation. Okay, I hope you understood this. Now let us take another problem for repeated case. Okay, so problem number 3. Okay, if the given differential equation is like this, d square plus 2 the whole square y, and this equal to 0. Okay, see here. So this is your given differential equation. So given differential equation, so we can write the auxiliary equation solution. Auxiliary equation. So what is the auxiliary equation? The auxiliary equation is given by we simply put auxiliary equation d square plus 2 the whole square equal to 0. This is the auxiliary equation. Okay, so we can write the two factor of this auxiliary equation, d square plus 2, this is the one factor, and d square plus 2, and which is the another factor, and this equal to 0. Okay, now we find the roots of this. So let us move for the next page. So this can be written as d square plus 2 equal to 0, or you can say d square plus 2 equal to 0. Okay, d square plus 2 and d square plus 2. Okay, now see here. So this can be written as d square equal to negative of 2, or you can say d square equal to negative of 2. This is the same equation, so there is no need to write, or you can write also. So this equal to what? This equal to plus minus square root of minus 2. Okay, or d equal to plus minus square root of minus 2. So this is equal to what? D equal to plus minus square root of 2, and square root of minus 1 is what? Iota. Okay, square root of minus 2 is iota. So this is what? D equal to plus minus square root of 2 iota. See here. Here you can observe that therefore d equal to what? Plus root is what? Square root of 2 iota in comma square root of 2 iota means what? Positive root repeated twice and negative root also repeated twice. So negative root minus 2 iota and minus root 2 iota. This is minus root 2 iota and minus root 2 iota. Okay, so for this we write complementary function. Therefore the complementary function is given by the complementary function is given by, what are the complementary function? Yc equal to, we write positive root, that is c1 plus c2x cos root 2x and plus c1 c2 is already done, so we take c3 plus c4x sine square root of 2x. Okay, here real part is 0, so we write here e raised to 0 x, or just solve this, so you will get c1 plus c2x square root of, cos square root of 2x and plus c3 plus c4x sine square root of 2x. Okay, so your complementary function will be what? c1 plus c2x into cos root of 2x plus c3 c4x into sine root of 2x. So which is the required complementary function of the given differential equation. I hope you understood this. If you like my video, please do share, subscribe and comment for the next video. Thank you, all of you.